Warm up for lesson 4-1. Pause to do the problem. Here's the answer. Pause to do the multiplication. Here's the answer. Pause to find the inverse. Here's the answer. Pause to set up the problem. Here's the answer. Lesson 4-1, Graphing Quadratic Functions. Objective, graph quadratic functions, find and interpret the maximum and minimum values of the quadratic function. Quadratic functions can have at most 3 terms. One term is called the quadratic term, and that is, it has a square in it. The other is called a linear term, it's to the 1 power, and the other is constant term. The graph will have this kind of shape, which we call a parabola. All right, let's take a look at how we would go about graphing a quadratic function. And if you go through a table of values, you're going to be able to get points to give you this parabola effect. Let's go to the next screen. And I'm going to try to start graphing this one. And I started with my points, 0, -3, and I graphed it. 1, 3, I graphed it. And it looks like with 3 points, I'm still not getting I'm getting the curvature, and it looks like it's going to be going down, but I still have a lot more points to go. There is a more efficient way to graph parabolas. So let's hold on and let's watch what goes on now. First, we need to understand some of the characteristics of a parabola, and one of it is that it has an axis of symmetry. So this axis of symmetry means that this can reflect over the other side. Now, this point right here that is on the axis of symmetry is called the vertex. What's very interesting is that these 2 points that have the same y-coordinate, the axis of symmetry is actually the midpoint between these 2 points. So if I were to take the 2 x's and I would take half of their sum, I would get 1/2 of 6, which is equal to 3. And the midpoint is, again, along this axis of symmetry where x is equal to 3. The same thing happens with these 2 points. They have the same y-coordinate. So let's just find the midpoint by finding the average of the x's. And we're going to get 1/2 of 6, which is 3. So the axis of symmetry is really all the midpoints between these 2 points that are on the same level, same y-coordinate. All right, let's do it again, but this time the y-coordinate is always going to be on the x-axis. And what we're going to do is we're going to find the axis of symmetry, and we're going to do that by taking 1/2 of the sum of the x's. 1/2 of -2 plus 4, so that's 1/2 of 2, which is equal to 1. This tells me the axis of symmetry is 1, and it tells me the vertex, the x-coordinate is 1, and the y-coordinate we can't find until we have an expression here. All right, the axis of symmetry is the midpoint between these 2 points. We're going to try to find 1/2 of the sum of the x's, and this will be 1/2 of -8, which is equal to -4. This tells me the axis of symmetry is x is equal to -4, and the vertex, the x-coordinate is -4, and we'll have to determine the y-coordinate at another time. Again, the axis of symmetry is the midpoint between these 2 points, so it's going to be 1/2, 4 plus 6, so that's going to be 1/2 of 10, and this is 5. So the axis of symmetry is x equal to 5, the vertex is 5, comma, and we'll determine the y later. This also happens with parabolas that turn down. So this is going to be 1/2, 3 plus 7, which is 1/2 of 10, or 5. So the axis of symmetry is x equal to 5. The vertex will be 5, comma, blank. All right, so we've discussed the idea that these 2 points are reflection, and the axis of symmetry is actually the midpoint between these 2 points. So, and we do have now a formula for finding the axis of symmetry. If you don't know these points, what we can do is we can take the coefficient of the x term, which is our b, coefficient of a, and which is 2a, and it's the opposite of b over 2a, and that's the x-coordinate of the vertex. All right, so why is that happening? I gave you a lot of examples with numbers. Now let me give you an example with the quadratic formula. The quadratic formula allows us to find where the parabola crosses the x-axis, and it crosses at these 2 points. So this is the x-coordinate, comma 0, and this is the x-coordinate, comma 0. These are where these 2 points intersect. And just like we did before, we're going to find the midpoint. So we're going to take 1/2, and I'm going to put this down. And I'm going to add it to the other one. Now they have the same denominator, and since they have the same denominator, I can write them up as 1 fraction. And while I'm writing them as 1 fraction, I notice that these two are the same, so it's going to be negative 2b. And I notice that one is a positive square root and one's a negative square root, so I know that's going to go to 0. I'm going to do a little reducing, and then my answer is going to be 1b, so I'll just write b in my numerator, and I have to put an opposite because there's an opposite sign, and the denominator will have a 2 and it'll have an a. So that's my axis of symmetry, which I have right there, and it's also the x-coordinate for the vertex. All right, here's a better way to go ahead and graph parabolas. Instead of just plotting points and not knowing what points to graph, you really ought to start at the vertex. Try to find your vertex. And what's very interesting on the parent function, this is the parent function right here, the rate of change is over 1, up 1 between the first point, between the vertex and this first point going over 1. And the rate of change from this point to this point is 3, and rate of change from here to here is 5. So it follows this pattern of 1, 3, 5, and 7. It also happens on this other side as well because of the symmetry. Okay, so let's go ahead and practice this. All right, so we're going to find the vertex, and remember the x-coordinate is opposite b over 2a. Remember that a in this example is 1, b is 2, c is negative 3. So this will be negative, and our b is 2 all over 2 times 1, and the answer is negative 1. So our vertex is negative 1, and we've got to figure out the y. To figure out the y, we're just going to put it back in to our function, and I'm going to get 1 take away 2 take away 3, and the answer is negative 4. So I'm going to have a negative 4, and I'm going to graph it negative 1, 1, 2, 3, 4 right here. So there's my vertex, and now I'm going to follow this pattern of going over 1, up 1, and then going over 1, up 1 on the other side. And then from this point, I'm going to go over 1, and then I'm 1, 2, 3. Go over 1, 1, 2, 3. And then starting from this point, I'm going to go over 1, 1, 2, 3, 4, 5. Over 1, 1, 2, 3, 4, 5. And now I'm going to have a pretty decent parabola shape. And I didn't really have to plot a lot of points. I was pretty efficient about my graph. All right, let's do it again. Notice that we do have our a here is going to be negative 1. And when it's negative 1, the parabola will have this kind of a shape. It'll go down. B is equal to 4, C is equal to 5. So x is equal to opposite b over 2a. Opposite our b is 4, and our a is negative 1. So we're going to get a 2. So 2 will be the x-coordinate of my vertex. My y-coordinate will be, as I substitute it in, this is going to be negative 4 plus 8 plus 5. So this is going to be a 9. 9. So I'm going to go over 2, up 4. Up 9. 1, up 2, up here, 9 right here. So there's my maximum because it's going to go down. I'm going to go over 1, down 1. I'm going to follow this over 1, down 1. So you have to go down 1. Now from this point, you're going to go over 1, but you're going to go down 3. 1, 2, 3. Over 1, 1, 2, 3. Now we've done 1, we've done 3, now we go over 1, we do 5. 1, 2, 3, 4, 5, over 1, and then 5. There's a lot of symmetry, and we could go ahead and draw our parabola. Pretty decent parabola. Now what happens if the a in front of the x squared is not 1? Okay, well if it's not 1, then you want to take that a and you're going to want to multiply it to the 1, 3, 5, and 7. So I'll tell you how high to go each time. So locate the vertex, take all these numbers here, and that's how you're going to plot them. For example, so right here we went ahead and we found our vertex, and normally we would have used the number 1 here, but because we have 2 here, we're going to take 1 times 2, and that's why we're going up 2. Normally this would have been our 3, but because our a is 2, we're going to times by 2. Normally this would have been my 5, but I have to multiply by 2. So this is why these stretches are a little different, and then you get a really decent parabola. All right, let's do it from scratch. A is equal to 2, and by the way, this parabola is going to go up. How do I know? Because a is greater than 0. B is equal to negative 12. C is equal to 16. So x is equal to opposite b over 2a. And b is negative 12, and a is 2. So my answer is going to be 3. So 12 divided by 4 is 3. So my x-coordinate is 3. To find my y-coordinate, I'm going to put it into the function. And I'm going to get 9, 18 minus 36 plus 16. The two positive numbers make 34. So that's 34 minus 36, and that's going to be negative 2. So I'm going to go over 3, down 2. Now this is the start. Remember the parabola's going up. Now I know the pattern is 1, 3, 5, but because my a is 2, I'm going to have to times each of these by 2 as I stretch up. All right, so I'm going to go over 1, but I'm going to have to go up 2. Over 1, up 2. Now from here I'm going to go over 1, but I have to go up 6. 1, 2, 3, 4, 5, 6, over 1, 1, and I'm just going to be right here. This is enough to give me my parabola shape, and I'm done. All right, so these low points are called minimum, and these high points are called maximum. And when our a is greater than 0, this is when a is greater than 0 over here, a is positive, then we're going to have a parabola going up. When our a is less than 0 or a is negative, we're going to have a parabola going down. Let's go back to some problems we've already done. This one we already did. We already found the vertex. Let's go ahead and talk about our max. So our max is going to be 2, 9, and our maximum x value right here, this is our maximum x value, which is 9. So our domain will be all real numbers. Parabolas have that. And our range will be, remember we're going to have a max, so we're going from negative infinity and we're going to go up to the number 9. Let's go ahead and take a look at another problem we've done. Our minimum is the point negative 1, negative 5, and our minimum is actually this right here. This is our x-coordinate, which is our min. Our domain is negative infinity to infinity, and we are going to start at negative 5 because that's a minimum, and we're going to continue having greater values. Okay, pause, and here are the answers. Pause, and here's the answer.